More options for faster image and video generation are here. These 3 test images I generated using Flux without a cache, with TeaCache, and also with WaveSpeed. Normally, 30 steps of Flux would take around 25 seconds, but here, the cached examples are down to just 15. Whilst the images aren't identical, faster generations can still be useful, especially on lower-end graphics cards. Whilst there are a number of options available, today I'm going to show you how to use your choice of 2 powerful ComfyUI nodes, WaveSpeed and TeaCache. Getting started is incredibly simple. Open ComfyUI Manager and then install either TeaCache or WaveSpeed, or both if you like. After restarting, just insert your chosen node cache right after your workflow's model loader. The GitHub page provided for the well-top ComfyUI TeaCache has some interesting information, such as why it's even called TeaCache. Turns out it's a time-step embedding aware cache. So not the usual British tea after all then. Still, the claims are you can get 1.4 and 1.6 times lossless speedups, or even faster, with some loss in quality, with LoRAs and control nets also being supported. WaveSpeed looks similar, with their dynamic caching being inspired by TeaCache. They also have an enhanced torch.compile node, but unfortunately that requires a more modern card than my crusty old 3090. If you are planning to get a couple of 5090s when they come out, then this could also be handy, as they plan to include multi-GPU inference too. If you're looking for demo workflows, they are, surprisingly enough, in the workflows directory, and they've got ones there for Flux One Dev, LTXV, and SDXL. Yes, this node even works with SDXL as well. A bog standard Flux workflow here to start with then, and I've added both the WaveSpeed and TeaCache nodes here at the beginning, right after the load model. The most important setting on either of these nodes is essentially how much cache are you going to apply. And in the first node, that's the residual diff threshold. Here I've got it set to 0.2. And in TeaCache, it's the rel L1 thresh. Here I've got it at 0.35. Now these values are obviously completely different, and the scales are different too. So very small changes in the residual diff will make quite big changes. So I tend to go around 0.125 to start with. That's a good area. Or if that's too much cache, then 0.1 is also a good one. Whereas with TeaCache, with Flux, you can start off around 0.4 and maybe drop it down to around 0.2. Any lower than that, not really having much impact. Interestingly enough, with TeaCache, which I'm going to show some examples for here, you can put a cache value higher than 1, which does some rather interestingly bad results, but I digress. Generally speaking, with all of these, both TeaCache and WaveSpeed, more cache equals more speed, but also more change. How much change? Well, let's have a look at some example TeaCache generations. Here on the left, I'm starting off with the base image, so no cache applied whatsoever. We've also got the timings there, so 25 seconds and around 1.16 iterations per second. Now I'm gradually going to increase the cache value, so the next one on the right there, starting off on 0.2 cache. Now that does look fairly similar to the base image, and it's shaved 5 seconds off the inference time. Not bad, so 20 seconds and 1.4. However, the next image at cache value 0.25 is very different indeed, as is the time with 16 seconds and 1.8 iterations a second. Continuing to increase those values, as you see, it does get faster and faster and faster. The next 3 then, 0.45 up to 0.55, and it is getting faster and faster. We've got up to 3 iterations a second there, just 9 seconds to run 30 steps, but the image quality is starting to degrade just a little bit. The final 3 then, 0.6 up to 0.7, the last one there taking just 8 seconds and 3.39 iterations a second. Of course, the quality does seem to have suffered somewhat. Looking at those images all together then, we've got the base to start with up in the top left and the fastest generation down in the bottom right. So it starts off pretty similar, but gets quite different. Well, hold on a moment. Wasn't this meant to be a 1.4 times lossless speed up? And yet here, all of the images change, and even the 20% speed up is the only one that's close. So maybe take those claims with a pinch of salt. I did try a bit more, but honestly with TeaCache, I wasn't able to get lossless speed up. How about using WaveSpeed instead then? I did the same again here, though more gradually increasing the diff value. As mentioned, much smaller changes in this than with the TeaCache. Now, with the first three, 0.05 cache, so very, very small value. That's 21 seconds, so we've shaved off 4 seconds, and it's almost identical, so that's pretty good. Tiny little change again on the next one, 0.75. That's down to 17 seconds, and also pretty good. The next three then, 0.1 up to 0.15, still getting faster and faster. Slightly different results, as you can see, to TeaCache. And then with the final two here, 0.175 all the way up to 0.2, which gives us the 9-second generation, and that's also fairly similar. Having a look at all of those together, then you can see, well, yes, personally, I think this is much better than TeaCache because it's keeping more consistent images, so we don't get those quite drastic changes. Back to looking at some workflows then, and as mentioned, I'm kind of preferring WaveSpeed at the moment. Not only does it work with SDXL and Fireflow, but it's also easier to run than the TeaCache node. Even if you turn that to false, unfortunately, once you've run it once with TeaCache, it will stay cached. There is already a PR to fix that behavior, so fingers crossed it gets included soon. Can we go faster still? How about if we combine it with something like the 8-step turbo or hyper LoRA? Well, this is where things get interesting. Take a look at this screenshot where it starts with 30 steps and around 1.6 iterations a second. However, as the steps decrease, the benefit of the cache also decreases, and by 8 steps we're hardly seeing any benefit at all. A quick comparison using the 8-step hyper LoRA then, once again the base image and a 6-second generation time. With a cache we can go a little bit faster, with 8 steps taking 5 seconds at 1.56 iterations a second. However, here's where the fun thing starts. Doubling the number of steps to 16 with a cache has only added 1 second, and I've got a speed there of over 2 iterations a second. WaveSpeed works with SDXL too, like in this detailed daemon example. In this test, it shaved off 3 seconds, and if we look at the two images, well, there's barely any difference at all. Whilst I have only shown image generation here, the same principles apply if you want to speed up video generation using the non-commercial LTXV model or the territory-restricted HunyuanVideo models, which, of course, for those reasons, I can't show you here. If you're using a cache with low-step workflows, then perhaps play around with the number of steps and perhaps you'll be pleasantly surprised increasing it ever so slightly. Either way, there's another tool in all of our toolboxes for faster generations.
Ooh, nerdy rodent. He really makes my day. Showing us AI in a really British way.